Good morning, everyone. So, as mentioned, my name is Dario. I'm business design lead at Nordic Bioproducts Group. I will now introduce a little bit about the company to give context and sort of like understand a little bit more about what Nordic Bioproducts does. So, I like to start a story about our two oldest sort of like get together and spark and decide to start something. I found myself in CHEMBIO that the world is actually quite small, so it's good to sort of like mention them. The core idea was to get together and to commercialize radical technology to really reduce the utilization of chemicals, water, and energy in the utilization of biomass. The company was founded in 2019, and we really are rooted in Aalto University as a spin-off, right? At the moment, we're a team of about 12 people with very different type of background, and really try to combine business development, engineering, and of course chemistry to really secure the impact of our innovations. Now, we are currently located in Espoo, just next to Aalto University, but we are as well setting up our first pilot plant, semi-commercial facility in Lappeenranta, and I will tell a bit more later about this. So, about our technologies, of course, the engine behind everything that we do. So it all started with one core technology, that is AltoCell technology. This technology or this process is being developed for the production of microcrystalline cellulose in a very efficient way from kraft pulp. Microcrystalline cellulose, or MCC, it's a product that it has an established market and is being used widely for pharma, cosmetics, and food application, but with AltoCell technology we can produce it much more efficiently and much more sustainably. So of course this was sort of like the catalyst or the initiation to commercialize this technology. The efficiency sort of like can be seen in the numbers, especially if it's implemented in a pulp mill kind of setup. So of course, because the process is much more efficient, we can utilize less energy, less water, less chemicals overall, and of course this allows a much more low carbon footprint overall regarding the product, the microcrystalline cellulose. Now, what this allows, and what has been a lot of work from Nordic Bioproducts Group in the last 2 years, has been to really show the market how MCC can now have sort of like new renaissance. It's a product that's been around for 50 years already, and it's been widely used, like I mentioned, specifically in quite narrow application. But thanks to this technology, what happens is that we can catalyze the market and we can start looking at whole new different areas where MCC can be utilized, whether MCC as it is or with modifications, for instance, in paints, in glues, in barrier, and so on. So sort of like we can start looking at more high volume application, where before MCC was just way too expensive, but we can also start seeing more high value applications thanks to AltoCell. Now this is the core technology where everything started from Nordic Bioproducts Group, so the commercialization of AltoCell. But then this sort of like parallel process started, taking all the knowledge, the cellulose chemistry, and sort of like the energy of our team, started developing a solution for the textile industry. So we started developing what is Norratex technology, that it's a process for the direct dissolution of cellulose from kraft pulp into MFCF, so man-made cellulosic fibers. This process started about a year and a half ago with the core idea of, okay, how can we maximize the utilization of kraft pulp directly into textile fiber? The core idea here is that we don't utilize carbon disulfide, and we try to minimize the utilization of harmful chemicals. We can utilize, like mentioned, the kraft pulp, so we don't utilize dissolving pulp. And this, of course, it's a key aspect within this discussion that we're having now, because by utilizing kraft pulp, we have hemicellulose present, and AltoCell process and Norratex process basically are working with kraft pulp who's rich with hemicelluloses. And from the beginning, Norratex process was developed to be very cost competitive, so to really have a sort of like a platform where we could produce a large scale of textile fiber, so really trying to be sort of fast to market with high volumes. We are still at initial stage, so we are still in laboratory setup with our fiber, but we have been producing enough fiber to have different type of samples that at the moment we are testing, we're kneading with, and we are having discussion, of course, with partners. We found it surprising. We were actually very motivated in the beginning. We thought it would have been sort of like more difficult from a certain point of view, but of course we found other type of challenges. But in the beginning, the dope was spinning very well, with the wet spinning. And the fiber itself is between viscose and cotton from let's say from a perception point of view. And yeah. Now, what these two technology opens up, and point of the discussion here, is the fact that the sugar utilization. So, for instance, with autocell hydrolysis process, what happens is that we have abundance of hydrolysate that is rich in C5 and C6 sugars, and this is what I like to call the sugar rose opportunity. And this is a little bit more about the frame of this presentation. So, what happens with autocell technology, with this hydrolysis process? What happens is that it becomes like a platform, or how we like to see it as a platform for really catalyzing and enabling biotechnology and synthetic biology, because we have abundance of this hydrolysate that is C5 and C6 sugars. It looks kind of like kombucha, and we've been utilizing it, of course, to start testing with microbes and so on, and so far it's having really good results, what we think. What happens is that with this platform, we're trying to combine these two areas of thermochemistry and biotechnology within one framework. And this is sort of like visualized. So Nordic Bioproducts Group, like Nina introduced, we've been focusing on the kraft pulp aspect because, of course, like this has been, let's say, the raw material for Altocell, and we see it as a stable product for instance, for Norratex. But we've been exploring, of course, with alternative input material and raw materials that, of course, are rich in cellulose. And so we can see this setup where we could utilize kraft pulp or alternative raw material within our process. And while we produce MCC or MCC derivatives or Norratex fiber as sort of like, let's say, primary products when the technology was developed and they justify the feasibility of the process, suddenly we have these C5 and C6 sugars that are available right on the side. It can be directly utilized. So, and this is, I think, that the main thing is that because the process has been developed with the idea that the cellulose part itself would justify the process, then the C5 and C6 sugars are available and they're quite efficiently produced, right? And I personally love this picture, but the idea is that we talk about zero energy loss C5 and C6 sugars as really sort of like the catalyst or the enablers from our side for synthetic biology and biotechnology in general. And this can happen in loco, for instance, in Lappeenranta, where we're setting up our first facility, where we're starting looking at different options to utilize these C5 and C6 sugars that are suddenly available. This is, again, just sort of like to visualize with one picture the fact that we can utilize kraft pulp or alternative raw material that we've been testing. By combining thermochemistry and biotechnology, we can start sort of like developing and initiating or catalyzing the production in larger scale of bioplastic foam, composites, bio-based leather, and so on. So this is the vision that we're looking for. This is a little bit like an opportunity map of sort of like what are the possibilities, what we're looking at, or where we're seeking partners. I think this is also something that, of course, we need the support and the knowledge from the synthetic biology aspect of it. We have been working, let's say, on the cellulose side of the technology and so on, and we're looking for partners, for collaborators who want to look into these sugar rows. They want to look into this hydrolysis and want to join forces with us, where we concentrate on the Altocell and Norratex side, but we need that support from the sugars and all that knowledge to then take full advantage of these C5 and C6 sugars. I would like to close with this summary picture. So we primarily utilize paper pulp, but we're really looking deep into alternative raw materials for our processes. Of course, there will need to be different type of pre-treatments and development of the technology to fit with these different raw materials. We have these two core technologies that are Altocell and Norratex, and despite we focus on cellulose-based products like MCC and MCC derivatives or staple fiber regarding Norratex, we have this availability of C5 and C6 sugars as most of you well know can be the raw materials for producing the next materials and the whole new movement of synthetic biology. And kiitos, thank you.